For our second lesson in 4.4, we're looking at 4.4b, proportional and non-proportional situations dealing with tables. And our goal for this lesson is to determine if a table is proportional or not. Now, for this lesson, we have just one thing of notes, and that's in order to determine if a table represents a proportional relationship or not, we want to use the formula for constant proportionality, which is k equals y over x. We learned that formula all the way back in lesson 3.1. So using k is equal to y over x, where we simply take the y value of the table divided by the x value of the table, and if we get the same value for k each time we divide the y by the x, then we're going to have a constant of proportionality, which means that our table represents a proportional relationship. However, if we get a different value for k each time, then we do not have a constant of proportionality, and therefore the table does not represent a proportional relationship. The table might still be linear, but it's not going to be proportional. So let's go ahead and take a look at a couple examples of what this is going to look like. For our first example, we have a table with x values 3, 6, 9, and 12, and y values 5, 10, 15, 20. So what we're going to do, we're going to take each of these y values one at a time and divide it by its corresponding x value to get a specific value. So let's go ahead and take a look at the first one. We have k is equal to 5 over 3. Now if you want to leave that as a fraction, that's fine. If you want to convert it to a mixed number or a decimal, that's also fine. All we're looking for is to determine if the value for k is the same each time. So that's what we're trying to find out. Alright, so for our first one, we have k is equal to 5 over 3. That cannot be simplified or reduced or anything, so we just leave it alone. For the next one, we're using y value of 10, x value of 6. So we have k is equal to 10 over 6. And if we look at that, we can see that those numbers can both be divided by 2. And so we simplify that to 5 over 3. So far, we have two k values that are consistent. We need to determine if the last two sets of pairs in the table represent a constant as well. So for our next one, we have k is equal to 15 over 9. And when we look more closely at this one, we see that this one has a GCF, or greatest common factor, of 3. We can divide both 15 and 9 by 3. And when we do that, we get 5 over 3 again. Okay, so still so far so good. Now we're going to look at our last ordered pair, where we have k is equal to 20 over 12. And we can see here that we have a GCF of 4 for these two numbers. So 20 and 12 can both be divided by 4. And again, we get 5 over 3. So if our answer for this one would be yes, this table does represent a proportional relationship, because it has a constant of proportionality where k equals 5 over 3. For our second example, we have another table. This one I set out horizontally, where the other one was set out vertically. Either way, we still have x values of 1, 3, 5, and 7, and y values of -5, -1, 3, and 7. So we're still taking the y values over the x values. So for our first one, we have k is equal to -5 over 1, and there's not really much we can do to simplify that, so we're just going to leave that one alone. We want the rest of our fractions to all equal -5 over 1. Okay, and we got that from this first row here. Moving on to our second row, we have k is equal to -1 over 3. Okay, again, y value over x value. So right away here we can see that -5 over 1 is not going to be equal to -1/3. Okay, two completely different values. Therefore, since we have the two different values, we know that our k values are different, and so this table is not going to be representative of a proportional relationship. So therefore, this table is not proportional. Okay, it doesn't have a constant proportionality, so this table does not represent a proportional relationship. It would still be linear. Okay, important to keep that in mind, that this table would still be linear. However, it is not going to be proportional. Okay, so if you were to graph this, it would make a straight line, but it would not pass through the origin. That's the key thing that we have to keep in mind here. Now, just kind of tying the whole lesson together, yesterday we looked at we looked at graphs and equations. Today we're looking at tables. So the big picture here is that, and I want you to write this down, in order to determine if tables represent proportional or non-proportional situation, here's what you need to do. You look to see whether the y-intercept of a linear relationship is 0 to identify proportional relationships for graphs, equations, and tables. Okay? So we're essentially looking to see if the y-intercept is 0. So when x is 0, does the y value also equal 0? And if it does, that's what we're looking for. Okay? So make sure you get these notes written down and post the pictures of them to the assignment, and we will talk more about this lesson tomorrow.